Hi all, welcome to part 3 of the video lecture on registers. So in part 1 and 2 we already seen a basic idea of register, how an n bit register can be made out of n flip-flops. That is what we discussed so far, and particularly that parallel in parallel out category. Okay, so we will explore it a little bit detail. So let's see a 1 bit parallel access register. So 1 bit register means what? It can just store 1 bit of information. So we should be able to load 1 bit into the register. Also we should be able to take this one bit out of the register. Some inputting 1 bit and taking out or the register is outputting 1 bit, like that. Okay, and as we are storing and taking in a parallel way, so we can call it as parallel access register. Access means read as well as write, right? So whether you want to write something into the register or read from the register, that is access, we are doing it in a parallel way. So that is the general terminology. So this circuit we already seen, but what you can see additionally here is a load input, okay, and a multiplexer also you can see, and multiplexer we already seen, right? This is what kind of a multiplexer it is. It is a 2 by 1 mux, and for this 2 by 1 mux there will be 2 input and a select line, and this is your select line, right? Select line, and whenever this select line, so that is nothing but our load input. So why need this load input? Because so far what we saw is like a D flip flop, and to this D flip flop, when we are applying this D to be 1, it is the output to Qn is found to be 1. If this D is 0, this is 0. So like that we saw. Now we don't want to, and also there is a clock also. So where during the positive transition, edge transition of the clock, this storage will happen. But we don't want it. Instead of that, we need some more control to the circuit, right? So there is a load input. So whenever I want to load, that time only I want the data to be inside the register. So that is my requirement. So whenever this load input is equal to 1, I want to load a new information into the register. Okay, but if I am saying that this load is equal to 0, that means I don't want to load some new input that is coming from the external word. Instead I want to retain the last information I am having. So that is the circuit. Okay, so what is the meaning? If load is equal to 0, what I mean is I want to retain the information. Okay, the last information that is stored, and when this load is equal to 1, I want to load some information. Here it is 1 bit only, but in general some n bit register you can think like this. From where? From some external source, right? External source. See, this is a type of circuit I am in need. So to have this control, we are using a multiplexer. A 2 by 1 mux is being used. Now what this 2 by 1 mux is doing, it is having 2 input and a select line, and you can see that one of the input of this 2 by 1 mux is the actual input from the external source. Okay, so this is your 2 by 1 mux. So one input is from the external word, and what about the other input? Other input of this 2 by 1 mux is the previous output, right? So previous output I am taking as input to the same circuit, means I am trying to retain the same information. So this is the retain. So if it is this load is acting like a select line. So whenever this select line load is equal to 0 means select line is equal to 0, right? On background it will select this, right? So something like this will happen. Yeah. So what I was trying to say is, whenever this load is equal to 0, this first input will be taken, and that means this will be coming in the output, right? This kind of a bridging will happen, that is retained. I mean the last information is giving as input again, and that will be retained, right? So this is your retain. Now if you are giving this load is equal to 1, this will be selected in the output, not this. Okay, and that time I will try to feed the external input to the circuit. Okay, so now it's clear, right? And rest of the things are just like what we seen already. So the 2 by 1 multiplexer is used to select whether to load a new value into the D flip flop or to retain the old value. Okay, Now the output of the circuit is the Q output of the flip-flop, that you know, right? So this is what I was saying. So whenever this load is equal to 0, this will select the this particular input, that is nothing but the previous output. So it will retain the information, right? It will retain the information. Now when this load is equal to 1, it will instead of retaining, the new information will be loaded. Let me write it here. New information loaded. So new information loaded when this control input load is equal to 1. So that is why how I want the circuit, right? So that's all. So load is equal to 0, then return the old value, load is equal to 1, then load the new information from the external source. So now the same concept you can extend as a 2-bit parallel access register. The same circuit you have to take 2 copies of it, right? So something like this. So the same one, first D flip-flop, this load I am applying same way as the select line for the mux of both. So now it's clear, right? So this is something we saw already. Same circuit I am taking 2 copies of it. It will act like a 2-bit and you can extend it to 3-bit parallel access register or some 4-bit parallel access register. Everything is possible. So when it comes to 4-bit, there will be 4 input and 4 output, right? So 4 input, and whether you want that input or you want to retain the last information, that is being decided by the load input. So when load is equal to 0, see all the multiplexer will be, when load is equal to 0, will be selecting this, so like this, that is also highlighted here. So whenever I am giving load is equal to 0, all the multiplexer will select the first input, right? Like this. And so the result is like this first input is nothing but the last information. So it will retain, everybody will retain the last information. Similarly, when load is equal to 1, the external input is being fed into the circuit. So this is where the actual loading is happening. Otherwise, it is retaining the last information. So we have this control over the circuit, right? So whenever we want, that time only it will store the information. It will load the new information from the external source. Otherwise, it will simply retain the last information it is having. So now it is more like a practical thing, right? So for that we added this load. Yeah, that's also here the same thing, but it is added with the clear and the preset input. Hope you remember the single input with which we can clear the circuit as well as we can do this resetting. Okay, this reset and clear. So the clear input is your reset. Okay, both are active low. So that also you can add, so that whenever you want to clear the circuit, you want to set the circuit, you can do accordingly simply by making this preset underscore n, that is the preset operation in the as 0, or the reset underscore n or the clear input as 0. So when it is 0, it will be activating because it is active low input. Okay. Okay, that about it. So just we saw the parallel in parallel out register only, but with that load input. Okay, that load control input. Yeah, thanks for watching.